Good morning. We need to show that this first limit is equal to 1 and the second limit is equal to e. So for this we are going to use the general theorems on limits. Let's read the remark first. Cauchy's first theorem on limits. If limit n tends to infinity on Sn, that is the nth term, if this limit is equal to L, then limit n tends to infinity on the sum of the terms divided by the number of terms. That will be also equal to L, the same. So now it is very easier to see that I'm having the limit on the sum of the terms divided by the number of terms. That means the format is same as that of using the Cauchy's first theorem on limits. So we are going to use here the Cauchy's first theorem on limits. Right? Let's move on to the second remark, that is the Cauchy's second theorem on limits. Suppose Sn is a sequence such that Sn is positive, strictly positive for all n natural numbers, and limit n tends to infinity on this Sn, the nth term, is equal to the limit L. Then limit n tends to infinity on this S1, S2 up to Sn, the power 1 by n, is also equal to L. So let's see in the second example, I'm having this format and the power is 1 by n. So it is clear that here we are going to use the Cauchy's second theorem on limits. Right? Let's move on to the solution. The first part. What is the nth term here? So let Sn is equal to, yes, what is the nth term? It is n the power 1 by n. And clearly, this Sn is strictly positive for all n belonging to the natural numbers. Let's check the limit on Sn. That is the limit on n the power 1 by n. That is equal to 1. It is always equal to 1. So now I am going to use the Cauchy's first theorem over here. So by Cauchy's first theorem on limits, because I am having the limit on nth term, that comes out to be equal to 1. So by Cauchy's first theorem on limits, the limit n tends to infinity on sum of the terms divided by number of terms should be also equal to this limit, that is 1. Yes, which means what is S1? It is 1. S2 is 2 the power 1 by 2. Yes, you can put here n equal to 2. You get 2 the power 1 by 2. Then S3 is, put n equal to 3 over here. You get 3 the power 1 by 3. Up to so on. Sn is n the power 1 by n. So this divided by the number of terms, that is n, is equal to 1. So we have shown that the required limit is equal to 1. Second example. What is the nth term here? It is n plus 1 divided by n the power n. Yes. And we are going to find the limit on Sn. So this is the notation, that is E. So therefore, by Cauchy's second theorem on limits, the limit n tends to infinity on S1, S2, S3 up to Sn the power 1 by n is equal to the same limit that we are getting for Sn. That is E. So which implies limit n tends to infinity, just write S1. This is 2 by 1, then S2 is, okay, 3 by 2 whole square, then S3 is 4 by 3 whole square up to so on. Sn is n plus 1 divided by n the power n. This limit, the power 1 by n, is equal to E. So we have shown that this limit is equal to E. So you just need to remember that if you are having the sum of the terms divided by n with limit n tends to infinity, then you have to apply the Cauchy's first theorem to find this limit. And if you are having the sequence Sn, right, the power 1 by n, then you have to apply the Cauchy's second theorem on limits, right? Okay, thank you. Stay blessed.